Welcome to The Explainer. Today, we're diving into a really fascinating and, pretty speculative idea that asks this huge question. What if you could describe the very first moments of the universe with a single, elegant piece of math? We're talking about the Nardelli master equation.
Just think about that for a second. The birth of our cosmos, all that energy, all that chaos. What if it wasn't just random noise, but was actually a kind of song, a mathematical one? That beautiful, poetic idea is really at the heart of everything we're going to explore today.
All right, so let's get into it. What exactly is this equation supposed to be doing? What's the claim here? Okay, so at its core, you can think of it as a proposed bridge. It's trying to connect the pure, perfect world of mathematics with the messy, physical reality of our universe's origin. It's trying to write one single rule that describes how the universe's shape, its geometry, and its growing complexity, or what scientists call entropy, evolved together right at the very beginning. So what's the big idea here? Well, the equation is all about a fundamental shift. It suggests that our universe didn't start as a chaotic mess. No, it started as something perfectly ordered, almost like a crystal. And then, at a key moment, that initial perfection broke. And that symmetry-breaking event is what kicked off the journey towards the complexity and the beautiful, measured chaos that we see all around us today.
So, what are the key pieces of this cosmic recipe? What kind of math do you need to tell a story this big?
This is such a cool way to visualize the main story. The theory says the universe began with this perfect, intricate symmetry, kind of like a platonic solid, where every single side and angle is identical. But then it evolved. It sort of relaxed into the simplest, most uniform shape there is, a sphere. And that journey from complex, perfect order to simple uniformity, that's the whole ballgame.
And what's driving this whole process? Well, it's a few very familiar mathematical characters. The equation suggests that these fundamental constants, pi, the golden ratio, and another one proposed by the theory, aren't just random numbers we find in our textbooks. Nope. The idea is that they are essential guides, practically steering the cosmos in that big shift from perfect order to the universe we know.
Now, this isn't some static idea that was just written down once and left alone. It's a living, breathing framework that has gotten bigger and more ambitious over time.
So the original version, the Nardelli master equation, was laser-focused on that one critical moment, the instant the universe's perfect initial symmetry shattered. It was all about that transition from the very first, highly ordered state into, well, everything else.
But then, the next version gets even bolder. The supermaster equation expands on the idea. It brings in these special numbers called transcendental numbers, like pi, that are absolutely key for describing circles and curves. And by doing this, it tries to connect the physics of the incredibly small, like particles, with the physics of the incredibly large, like galaxies.
And this brings us to the latest evolution, which is just fascinating. This version links the whole framework to the mind-bending work of the legendary mathematician Ramanujan, and even to concepts from string theory. It puts forward this wild idea that the golden ratio acts like a universal point of balance, a cosmic attractor that's basically pulling the laws of physics towards a stable state.
So, you might be thinking, why does a super theoretical, highly speculative equation like this even matter? What's the point for physicists who are actually trying to figure out how the universe works? Well, its biggest ambition is to help solve one of the toughest puzzles in all of physics, quantum gravity. You see, we have one set of rules for the big stuff, like planets and galaxies. That's Einstein's general relativity. And we have another set for the tiny stuff, the quantum world. The problem? They don't play nice together. This equation hopes to be a new mathematical language that can finally unite them.
And because of that, people who work on this believe it could be a really valuable mathematical toolkit for finding a theory of everything. It offers new ways to look at ideas in string theory, new models for how our universe inflated right after the Big Bang, and it lets us explore that incredible idea of the golden ratio being a kind of fundamental anchor for the cosmos.
Okay, let's just step back for a second and look at the big picture. When you boil it all down, what's the main takeaway from this whole idea? When you get right down to it, the Nardelli master equation is this bold attempt to show that the physical laws of our universe might not be random at all, that maybe they come from something deeper, something elegant, from pure mathematical structures that were there from the very beginning. So, in the end, this whole thing isn't just about physics, and it isn't just about math. It's about the deep, mysterious, and powerful relationship between the two.
It suggests that if we really want to understand our universe, we have to appreciate the incredible harmony between the way things are and the beautiful math that seems to describe it all so perfectly.
And that leaves us with a really mind-bending thought to chew on. An idea like this forces you to ask a truly fundamental question. What if the universe isn't just described by mathematics? What if, at its deepest, most fundamental level, the universe is a mathematical structure? Something to think about.